today. And yeah, I'm happy to continue the discussion and presentation from SAP on relative location. Now in my session, we are talking on a global world frame, so to speak, and how to define where things are on a, as said, global scale. But first of all, a few words to myself. Yeah, oops, that was too far. 1 second, give me a second. So, no, seems, yeah. 1 second, yeah. Now, yeah, here we go. So, who I am, I'm Matthias. Yeah, and that is also a great thing of the OPC Foundation, that many experts from different fields join in to define how industry is being built in the future. So I have a background in geoinformatics, so I'm not an industry folk. So I'm dealing with location-based services, with navigation, mapping, finding things. I run a sort of small software company. I joined OPC or my company last year. And I'm also committee leader for Omlox. Omlox is a locating standard that is hosted by Profibus. I think most of you might know this association, coming more from the industrial communication field. And we in Omlox take care how location data is processed and generated for moving things. But that's only one part of the game. And as Stefan also mentioned, we need to have collaborations. We need to get the data flowing from A to B in a seamless manner. And therefore, yeah, we are engaging also with OPC to work on a global level. And yeah, so, and the background of all of this is, of course, everything moves in production, in logistics. We have seen the world frame, the relative spatial location example that SAP has mentioned, but of course, a world frame, so in this scenario, is somehow located on a globe. And we are not only in buildings, but we have seamless scenarios. So robots are moving, robots are mounted on an AGV. And so everything is sort of flowing, and therefore it's important to know where things are. And my little presentation today has 4 little aspects. So I want to talk on the use cases, why this is needed. I'm going to give you an insight how location is being defined in the different OPC specifications, and then I'm going to argue why we need to have to align this and have a global perspective, that everything works nicely together like Lego bricks, also from the location perspective. And then I'm going to talk on the initiative that we are about to start in the upcoming weeks, so that you are invited also to join in to contribute to this new endeavor that we jointly want to do. Yeah, so location use cases. I think these days we all experience that location is an important topic. We experience supply chain differences or difficulties. We experience lack of goods. We experience also in pandemic times, knowing where people are, how many people have been in a room, who met whom. So location is very ubiquitous. And of course, in industry, there are many use cases that deal with location data. Of course, one no-brainer is asset management, finding things somewhere in the production side, in logistics. On the one hand, to optimize processes, to automate, but also to use assets more efficiently. And that has also some aspect on sustainability, decarbonization, CO2 footprint. So using assets efficiently. And of course, when things are moving, logistics, the location changed. Also there are a lot of use cases in warehousing, in intralogistics, in supply chain management, you name it. So there is a huge bunch of use cases. Then, of course, machines need to be operated, maintained, and also there you need to know which machine you are maintaining, where to go, how to find them. Also there are a lot of use cases associated. And of course, we all aim to automate things on the one hand to be more efficient, but also lack of labor, finding educated people is a challenge in many countries, at least these days, and therefore also automation tasks are relevant. And when things are moving, of course, a digital system needs to be aware that something has been moved. So, for example, in the warehouse management or in the production planning or in the enterprise resource planning. So you need to transfer the movement to a digital system. And therefore, yeah, all these manufacturing execution systems, they need to be aware that something happens. And the challenge now is for in real life, of course, many different applications, different devices, different locating technology, especially indoors, different wireless technologies. So it's sort of a huge mess, and we need to work on that. And with Omlogs, we try to solve the aspect on how to get the location data. And now, jointly together with the OPC and AIM, another foundation that joined in, we're going to define how the data is then processed, used in alignment with the already existing specifications. Stefan also mentioned the harmonization working group. So there is something that we need to take care that everybody has the same understanding. And location data, there are different approaches how to get to location data. And we have seen in sub-examples, we have the relative location aspect. So you can define a location relative to another location, like the frame example in the robotics use case. And of course, you can somehow have a global perspective, or even, as you see on the picture, an even global, more global perspective to define in a coordinate system, for example. And then we can define locations geometric with positions, with vectors, with coordinates, or semantic. A thing is left to another thing or on top of it, which has some meaning, especially to the viewer, to the one who is managing a system, to us humans. So there are different approaches how to define things. And what we're now going to do or aim for is to work on a common understanding of everything that is somehow, oops, why this is not going. Yeah, here we go, a little bit lag. So everything that is in a production site, we want to know where things are: a product, a machine, a robot, a tool, an industrial truck, an AGV, and drone. Also, as humans still being on production sites, so that we know, or things know of each other, especially if production is getting more and more dynamic, and also logistics is getting more and more dynamic. We have more and more AGVs, robots moving around. So a common understanding is necessary from different perspective, of course. And yeah, that is the aim of this initiative, to come to a holistic understanding, to allow also for a seamless locating outdoors, indoors, so that there are no barriers when locating. There are no technical barriers, but also from the semantics and understanding, there are no barriers, and every stakeholder in this production industry domain can understand who is neighbor, where are things. So to have this holistic view, that is the idea and the concept. And of course, location is not new, also not new to OPC, and there are a lot of specifications, either core specifications or complementary specifications, that already deal with location data. So this initiative is not starting by zero. We have something that we can work on, that we can refine, that we can adopt. And so here you can see a list of examples, and there are even further in all the companion specification, or in many, some location aspects are touched, even in this laboratory environment. Also there, location is an aspect when you have these laboratory use cases. But for the time being, I will concentrate on the general information model. Also SAP has mentioned this already. Then the machinery part, then a companion specification that is even more precise. And yeah, other location specific or companion specifications where location is being touched, the relative spatial location have been seen, and I think Manfred will talk a little bit on asset management, where also location plays a role. And yeah, in the general information model, we have this XYZ coordinates being defined as Cartesian coordinates, having means in a Cartesian space to define things. And of course, when the first locating use case has been started, one had the more indoor use case in mind, having a production site, a hall where you have a certain point where you can start to refer to, and then compute locations in this coordinate system, in the Cartesian coordinate system, according to this hall or to this space. And in order to complement those, the vector, the 3D vector is defined, and also some orientation, and also a framing where you can assign a certain frame to a position and its orientation. So as said, in a given space, define where things are, and the relative spatial location subspecification have used this schema to refer to things in a relative environment. And then on the opposite side, we have a companion specification where location is just defined as an arbitrary string that can be, as you see in the example, Munich A2 217. This could be a city, Munich. A2 might be a hall, and 270 might be a certain area. So there is semantic associated, somebody who can read this and knows the location, knows where this thing is. But of course, if you want to compute something, this is quite hard to come to a common understanding. Having the understanding Munich could be Munich, the city in Germany, but I'm confident there are also other cities that might be called Munich in the US or in other places. So it's not free of ambiguity to see and compute with this. So that's the other spectrum that we have. And then a couple of years ago, with the support or from the Auto ID community, we have a companion specification, or OPC has a companion specification for Auto ID. And there the use case is identifying things on shop floor or in logistics, especially with OCR systems, with RFID, for example, with camera-based systems. And those Auto ID technologies have been, or typically are used in also on the one hand in production, in line-based production system, but also a lot of in logistics, especially for pallets and larger goods where you want to identify a bulk of things. And therefore, in this companion specification, we have already a first understanding on a global schema, and that is defined here. We have data type, which is VGS84, spatial reference system with a latitude and longitude definition on a global schema and some altitude. And so you can see already there is an aspect being touched. And then in the new relative spatial location, we have this framing schema, and in the asset management, we have also a certain element already been defined about hierarchies, where things are, whether a thing is in a certain area. So my message for this block is already in OPC, there are many locating aspects being touched, and with a certain background, with a certain purpose, but to our understanding, an alignment is needed, and also an extension, and that is what I'm going to tell you in a minute. So having a global coordinate system, and you see here the picture of a map and the compass and how people have been navigating around the globe in ancient time. Yeah, it's a challenge to identify locations on a globe. If you want to have a high precision, and in some scenarios, the global coordinate system, VGS-84, or satellite-based position system, is not enough. And here is a short visualization where you could imagine that, yeah, we are living not on a ball, which is ideally a round shape. We are living on our little tiny planet is in geoinformatics one would call a geoid. So it's a certain type of shape. You can see here this video from ESA. They did a 3D scanning of the planet. You see the different land masses, you see the water, and this thing is not round. And so having a positioning system that matches this thing is a challenge. And why it is? Next slide. You can see, yeah, already 100 years or many years, people trying to describe this planet where we are living on a flat plane. And there are different means to do this. You can see here some examples. You have a cone, for example, or you have a blade, and you are projecting the Earth's surface on a flat plane. And when you do this, you have always certain deficiency, something that is not working right. Either it's the angle, it's the distance, or the area. And so you have always to deal with the fact that not for every place on the globe everything is matched accordingly. And you might have seen in the past some pictures of the globe where Africa is as large as Greenland and Russia is larger than Africa. In reality, this is not the case, but due to these projections, it appears to be, and of course, that has some impact, and especially if you are in high precision industry scenarios, where it's about 10 centimeter could be damaged or hurting somebody, or a robot is putting something on a pallet. So the global reference frame should be in the right setup. And on a global scale, we are doing this with this VGS-84. I don't know why this picture is not shown. Here it's going, where we divide the globe in certain latitudes and the longitude, and you have certain spaces and coordinates where you can pinpoint where things are on the planet. And this is for many logistics use cases. It's widely adopted. Everybody is using the GPS format to navigate. But also there we experience that GPS is not 100% precise. The satellite signals are not always being received very well, especially in urban environments. So also this type of locating system has some challenges, especially if you need high precision and 1, 2, 3 meters are not enough for the use case that you are targeting at. And for that reason, there are other coordinate systems that one can use for different purposes. We at Omlox, we have decided that we use, in addition to VGS-84, that is also described in this AutoID companion specification, we have decided to use UTM. That's a certain way of slicing or projecting the globe on a flat on a plane, and there you have certain type of cells that also are defined. And the positive side is that you are in a number of where when you are in GPS coordinates, you can reach 10 centimeter, 20 centimeter precision. In UTM, you can reach a precision sub-millimeter way, and therefore That's another projection that can be used for those use cases where high precision is needed. But that is not the only one, and there are even more. And therefore, it's necessary to have the flexibility to use different projections, but also to know which projections are used, to also translate between the different projections so that everybody knows what is the global reference that something is using to refer to a space, and how to compute this. And therefore, as said, the idea of this working group that we are planning is to define which coordinate systems are needed for the different companion specification, for different use cases that we are targeting, for robot, for vision, for logistics, for all the others, to have a defined set of coordinate reference systems that can be used either in the relative locating use cases to refer to, or if you have systems running that always use global coordinates and follow a drone flying in the hall on the global scale, not relatively, that you are then also have the common understanding. And that is the summary and outlook. So as said, we have already in OPC a lot of touch points of location, but some harmonization is needed. And for the high precision use cases, VGS84 is not enough. We want to open this up for having other global reference systems. And for that, we initiate a new working group together with AIM. They have started this GPS input in OPC already. We from Omlox, as part of Profibus, we have been taking care of how to compute this location data with different locating systems, ultra-wideband, Wi-Fi, Bluetooth. And by having those different groups together, I think we are well set up to define this for the benefit of all and to come to a joint understanding. Yeah, so that was it. And I hope there are some questions. If not, just reach out, and soon we will publish the corresponding call for experts, and you're invited to contribute, to join into this initiative and the working group, and shape with us how location data is being used for the global scale for OPC. So thank you.